Good day, everyone. So today we shall be diving into hydraulics and pneumatics machines. In this topic, we'll be understanding the science of liquid and gas pressure for mechanical force and control. So let's dive in today. Now, first of all, let's look at what hydraulic and pneumatics are. When we say hydraulics, hydraulics actually is a branch of science concerned with conveyance of liquid through pipes and channels, especially as a source of mechanical force or control. On the other hand, pneumatics deals with air instead of liquid. So we could say that pneumatics is a branch of science concerned with conveyance of air or gas through pipes and channels, especially as a source of mechanical force. So the difference between hydraulics and pneumatics is that where we have liquid, we replace with air. And the main function of this liquid is to be used as mechanical force. Now, there is a point to be noted here that hydraulic system operate at higher pressure than that of pneumatic system, thereby producing larger forces and torques. As you can see here, this young man is making use of hydraulics because as he exerts his weight on this piston here, the piston presses the liquid, which invariably moves this car upward. So this is a typical example of a hydraulic system where you make use of the liquid as mechanical force in pulling an object. All right. So now we have some other simple hydraulic and pneumatic machines. Number one is the simple force pump. A good example of the simple force pump is the bicycle pump. As you can see, this young man here using the bicycle pump to pump his bicycle tires. So the bicycle pump actually moves air. As he applies his force on the piston, air is being moved from the pump into the tires. That's how it works. So it is the air now that applies, is the air movement that actually increases the air in the tire. Okay, the bicycle pump moves air into the bicycle tire. Another one is called the suction pump. Another simple force point, suction pump. In this case, instead of making use of air, make use of liquid. Okay, suction pump actually lift liquid from low level to high level. That's the work of suction pump. It's another example of simple force pump. Then we have another pump called the centrifugal pump. This centrifugal pump uses moving vanes to receive fluid, either air or water, at smaller radius for efficient transfer. As you can see here, this is a typical example of a centrifugal pump. So here, the centrifugal force is inserted into the liquid, and the liquid is being moved from the reservoir out of it to the pump outside. Okay, the one we use as our pumping machines in our various homes. So it takes the water from the well and then takes it out to wherever it needs to be taken through a smaller radius. You can see the smaller radius here. So through a smaller radius, the water is being taken and being lifted out. This is another example of hydraulic machine because it's making use of liquid. Why the bicycle pump is an example of pneumatic because it's making use of air. Then we have the hydraulic jack. The hydraulic jack actually discharges its own action by moving liquid from lower pressure to higher pressure. You can see here now that this piston presses this liquid down here, and the liquid pressure is being transmitted to the other side, which invariably moves this car upward. This is an example of an hydraulic jack. So it jacks this vehicle upward because of its pressure from this end to the other end. All right. And this is another example of hydraulic system. Okay, so we still have more example of this system of pneumatics and hydraulics. Like we have the garden sprinkler. So okay, the garden sprinkler actually revolve round as a sprinkle water around the garden. Okay, it has no nozzles where the water being ejected out as it revolve around. As it revolve around and it sprinkle the water in the lawn. You could see it here. So all this water you're seeing here, they're coming from the nozzle of the sprinkler. As it's rotating, the water is being ejected and it's being sprinkled on the garden. So it's another hydraulic system. We have the reaction turbine. This converts fluid pressure into rotational or mechanical energy. So this reaction turbine, what it does is that the fluid, in this case, let's say it's water, it converts it into a rotational mechanical. So it turns the water round and round, which invariably moves any object that is required to be moved. All right. And the last one of this pneumatic and hydraulic system is the water wheel. The water wheel uses flowing water to generate mechanical energy for mills and machineries. So as the water is being poured, okay, the water is being poured from maybe from the river, it turns this water wheel, and as it turns this water wheel, invariably the water wheel turns the mill machine that are used in the industry for different purposes. Okay, so what are the other applications of pneumatics? We've already said that the pneumatic makes use of air, right? So one of the areas of application of pneumatic is in air brakes. Okay, we have brakes in our vehicles, in buses, in trucks, they make it of these air brakes. Train as well make it of this air brake for reliable braking system. Okay, another area of application of pneumatics is in air compressors. Okay, so it generate this air compressor generate compressed air for industrial and commercial applications. We also make it of pneumatics in air engines. Okay, this air engine okay also are used in powering some vehicles and machines. And we have the pressure sensors that are used to monitor and measure pressure level in various systems. The fifth application is in pressure regulators. We use pneumatics in also designing pressure regulators that are used to control and maintain consistent pressure in pneumatic systems. And then we have the vacuum pump. This particular one creates negative pressure for specialized industrial uses. So these are some of the applications of pneumatics. So just like the pneumatics have application, the hydraulics also have their own application. For the hydraulics, we have the hydraulic press. The hydraulic press actually generates enormous force for metal forming, stamping, and manufacturing processes. Then we also make use of hydraulic in boat and airplanes. The hydraulics control surfaces and landing gear. Okay, because the landing gear of plane okay depends solely on hydraulic powers okay for precise operation. So if there is no hydraulic powers, plane will not be able to land uh, properly. So we also apply this hydraulic in vehicle brakes. Just like we have pneumatic brakes, we also have hydraulic brakes too. So we use them in cars, we use them in motorbikes, in bicycles, and other hydraulic system to force brake pad against wheel. So we know what brake does is to stop a vehicle from moving. Then we make use of hydraulic in heavy equipment like the excavators and dump trucks. Okay, they make use of this hydraulic piston to control digging and dumping equipment. And lastly, we also make use of hydraulics in our office chair. You could see a typical example here. So the hydraulic cylinder enables smooth height adjustment in ergonomic setting. So you probably would have seen this kind of seat where you can increase the height or decrease the height of the seat. This is possible because of the hydraulic cylinder that allow the pumping of air and the compression of air. It's as a result of the compression of air and the expansion of the air that makes this chair to go up and down. All right. So these are the various applications of both pneumatic system and hydraulic system. Right. Now we want to compare these two. The comparison between hydraulics and pneumatics. Okay. Now the operating medium is the first thing. In hydraulics, the operating medium is the liquid, okay, typically oil, while in pneumatics, the operating medium is either air or gas. Then the pressure levels. Hydraulic system operate at much higher pressure than pneumatic system. That's another difference. Now, the force outputs. Hydraulic produces much larger force and torque due to higher pressure operation, so that we have more forces produced by the hydraulics than that of the pneumatics. So these are the three major differences between the hydraulics and the pneumatics. So what are the key takeaways in the lesson of today? Two distinct technologies we have mentioned, and that is the hydraulics that make it of liquid for higher forces, and the pneumatics that make it of compressed air for lighter duty operation. Again, these two technologies are widely applied in our everyday life, starting from the simple bicycle pump for pumping the tires of the bicycles and to the complex industrial machineries and transportation systems. So, what are the complementary strengths? As we've said earlier, the hydraulic excels at higher force application. However, the pneumatics offer cleaner, simpler solutions for many industrial uses. Okay, now real world impact. Everyday life, we use it in our braking system, we use it in our offices for our seats, we also use it in our garden irrigation, we use it in our compressed air tube, and for the industrial aspect, it is used for every construction equipment, it is used in manufacturing presses, it is used in transportation systems and power generation. So we have looked at the major applications of these two powerful technologies, and then we have seen that they are very, very important in transportation and other modern industry. So that will be the end for the class today. I hope you have learned something today. So permit me to call it a day. Thank you for watching and have a wonderful day.